This class is a continuation of the topic orbital. Do you remember that in our class on orbitals, we ended the class by mentioning that orbital types have maximum number of electrons that they can carry. S orbital has the maximum of 2 electrons that it can carry, that is 1 times 2. The 1 means 1 degenerate. This 2 stands for 2 electrons. So S orbital can carry a maximum of 2 electrons. P orbital can carry a maximum of 6 electrons. How? It has 3 degenerates, and each degenerate can carry a maximum of 2 electrons. 3 times 2, 6. The same thing with D orbital, a maximum of 10 electrons, because it has 5 degenerate orbitals. F orbital has a maximum of 7 degenerate orbitals. 7 times 2, 14. How can we apply this? In our previous classes, we were taught how to write the electron configuration of an atom of an element using the simplest method. For example, magnesium, its electron configuration using the simplest method is 2, 8, 2. That is 2 electrons in the first shell, 8 electrons in the second shell, and then 2 electrons in the last shell, which is the third shell. However, what if you are asked to write the electron configuration of magnesium using the SPD notation? How are you going to do it? You need this information here, which we call the off-Bohr principle, which explains how an atom is built up from the shell which has the lowest energy level. Here you have 1s, that is the first shell. You also have 2s and 2p, 3s, 3p, 3d, 4s, 4p, 4d, and 4f. You know what the letters mean, orbitals. Do you know what the numbers mean, the coefficients? Do you know what they mean? Shell. This one means first shell. This 2 means second shell, third shell, third shell, fourth shell, and then fourth shell. How can we write the electron configuration of magnesium using the SP notation? We draw diagonals like this. We follow the diagonals. When we fill 1s orbital, we go to 2s orbital. After that, we come to 2p orbital, then 3s. After 3s, go to 3p, 4s, before we come to 3d, in that order. So let's start with magnesium. The atomic number of magnesium here is 12. That means it has 12 protons. Remember the rule of zero net charge. 12 protons, it will also have 12 electrons. So that plus 12 minus 12 equals 0. These 12 electrons, how are they going to be arranged? 1s2, that is, we fill the first shell, the s orbital of the first shell, we give it only 2 electrons. Why? Because s orbital can carry a maximum of 2 electrons. Do you see that? After filling 1s, we go to 2s. 2s is here. 2s2, because s orbital can carry a maximum of 2 electrons. Remember, we have 12 electrons. We remove 2 here, 2 here, remaining how many? 12 take away 4 is remaining 8. We'll move on. We'll go to 2p shell. 2p. 2p can carry a maximum of 6 electrons. So we'll right here 2p 6. And then after 2p 6, we'll take 3s. 3s what? Do we have up to 2 electrons? Yes, we have up to 2 electrons. So we have 3s2. It is this method, this off-Bohr principle that you always apply. This principle and then this table, you can apply them whenever you want to write the electron configuration of any element at all in the modern periodic table. Do not forget that. If you have any question, we'll meet again in the next class.
Must not close.